All right, so today we're going to go into chapter 2, okay, of our physics form 5, okay, and we're going to be talking about pressure. So before this, we talked about force. And just before we begin, I want to remind you of a formula that you probably have learned when you were in form 3, okay, which is the pressure, okay, equals to force over area. Okay, ini sebenarnya kamu sudah belajar sebelum ini. Okay, so pressure equals to force over a surface area. And we are going to be using this formula a lot today. I also want to remind you of another formula that you may have learned when you were in Form 1, which is density equals to mass over volume. Okay, if you don't remember, this symbol over here, which we call rho, okay, the symbol is rho lah, but it looks like a berudu yang sedang berenang ke arah atas. Okay, so that is the formula for density. Okay, dan all this dia ada berkaitan lah with what we want to talk about today. Okay, so the first thing we're going to look at is this idea of pressure inside liquid. Okay, and to give you an idea, let's take a look at this video. This video is a bit too long lah, but we'll just, oh dear. Okay, this video is a little bit long, but I just want you to take a look at what's happening lah. Can you see the video?
Yes, yes.
Okay, so you notice that there's a lot of water, okay, that's gushing out lah. Okay, the water is flying out very fast. Okay, and at certain places kan, wow, very nice to take photo. Look at the cute dog over there. Okay, but actually what I want you to notice, so this is a dam. Okay, notice that the place where the water is coming out from, I don't even know whether I can be heard, but notice the place where the water is coming out from, right? The water is coming out very fast. Okay, it's coming out very fast and it's traveling very far. Okay, it's pretty amazing lah. This is a dam, dam as in empangan. Okay, so as you go higher and higher, notice how high the dam is, and notice the water behind the dam. Okay, is astaga. Okay, so this is another situation, also a dam. Okay, also a dam, and take a look at the other side of the dam. How fast the water is coming out from the dam. Okay, take a look at how fast the water is coming out from the dams. It's pretty strong lah. Actually, you wouldn't want to be swimming on this side of the dam lah. You want to swim like, if you want to swim, you want to swim like before the dam. Okay, so so the thing that we're going to learn about today has something to do with that dam structure lah. Okay, this is another one. Take a look at before the dam and after the dam. So after the dam, the water is coming out at a certain speed. Okay, so the question is, why is it coming out like that lah? Oh, this video is very long and it's all about the same thing. Okay, so here's another one. So when you first open the opening, notice the dam when it's first opening, the water is coming out very slowly lah. Okay, but take a look, the dam opening, right, and the water surface is pretty much the same level. Okay, so notice that, okay, the water is coming out very nice and very slow, like very calm lah. Bukan macam tadi kan yang keluar macam banyak begitu. Wah, hebat loh. Saya boleh jadi commentary for all the videos. Okay, so notice the big difference. There's a big difference between the situation just now and this one. Okay, so this one is like, wow, okay, the water is coming out very slowly. How come just now the water is coming out very fast? Very fast and very strong. This one is like trickling down lah. Okay, oh dear. Oh, this video is very long. It is 10 minutes long. Okay, sorry, skipping. Okay, so this is another one. Water is coming out very fast, also for some reason. Okay, here's another one. Water is also coming out very fast, also for some reason. Okay, another one, and another one. Okay, look at how high the dam is. Okay, why is it that the water is coming out very fast? Okay, is the question we want to talk about lah today. Okay, so yeah. Okay, so it's a Japanese version of the same video. Okay, look at how fast the water is coming out and literally how high the dam is. Okay, okay, look at this. Okay, it's a very standard height of the dam. Look at the height of the dam, very high. Okay, okay, this is another one today. Wow. Okay, maybe I should like. Okay, anyway, this one lah. I don't know what language this is, so. Okay, anyway, yeah, so you can see lah. Okay, more pictures of the dam. This is a calmer version. Okay, and of course ini yang kita nampak tadi lah. Okay, the one that's like super calm. So the question is this lah. Okay, why is it that the outlet of the dam, you notice that just now the dam, let's say if I draw the dam from the side view, right? Okay, so let's say this is the dam lah. Okay, and then this is the water level. Sometimes you will notice that the outlet is very near the base. Okay, this is where the water is coming out. Okay, some of it, like just now we saw the outlet is up here. Di sini air keluar. Okay, but we notice that when the outlet is very near to the base, to the bottom of the dam, okay, we notice that the water shoots out very fast and very far. Okay, this is very logical. If you've done this at home before, you will know. Okay, so these are the questions that we want to ask when we are talking about pressure in liquid. Okay, and not just water pressure. We are talking about any kind of liquid. Okay, they will exhibit this characteristic. Okay, astaga, sorry. Okay, so in order for us to understand this concept of pressure in liquid, we need to know how to derive this formula. Okay, which is a formula for pressure in liquid. We can count how much pressure, okay, that a liquid will mengenakan di atas satu object. So we start from this formula that I mentioned just now, which is density. Okay, so density equals to mass over volume. Okay, which is the first one. Okay, this is actually in your textbook now, but I need you to look at this first. Because we need to learn how to derive the formula of this one, P. Kita mau pergi dari rho sampai P. Okay. Now, if you take a look at this object over here, we know how to count the volume from mathematics. Volume is the base area times the height. Okay, so luas tapak darab dengan tinggi is always the volume. Okay, just like cylinder, dia punya luas tapak is actually a circle. Right? So luas tapak is actually pi r squared, and then the tinggi is h, so it's pi r squared h, which is the volume of cylinder. But for for a box, okay, the base is actually, we call it the area of the base, we call it A. So A times h will be the volume. Okay, so let's say I substitute the volume in here. Okay, and I make the kepala rumus as M, I will get rho V, which is actually rho AH lah. I substitute the V as AH, and then I switch this around so that saya jadikan M sebagai kepala rumus. Okay, so I get rho AH. Now, the other thing that we learn is weight. What is the formula for weight? Banyak kali sudah kita cakap ni.
Mg.
Okay, weight is actually equals to mass times gravity. So we put mg over here. Okay, now since m is equals to rho ah, okay, why don't we put rho ahg, okay, over here. Okay, and then I said just now that that one of the first few formulas you learned last time is this one. Pressure equals to force over area. P equals to F over A. And in this case, our F, our force is actually weight. Okay, so let me put it over here. So since my pressure is equals to weight over area, and my weight is rho AHG, so I will get rho AHG over A. di mana saya boleh potong the two A's and I will get rho H G. Okay, and this is the formula for pressure in liquid. Pressure in liquid is P equals to rho as in RHO, okay, rho GH. Can be rho HG also lah, tapi saya rasa kita punya standard is rho GH lah. Okay, where rho is the density of liquid. Okay, G is gravity, which we know as 9.81, and then H is how much is inside the water. Okay, the height of the water, the height of the liquid lah. Okay, and that's how we calculate the pressure of the liquid. So the thing that I need you to know is how to derive this lah. Macam mana mau pergi daripada rho then sampai ke P. Okay, so this has to be remembered, and I think it is in your textbook in page 40. Okay. Sorry. Okay, so can you take some time to write this down in page 40? The formula for the pressure in liquid, okay, if you look at page 41, it's written like this lah, H rho G. It can be rho GH, it can be rho HG, it can be H rho G lah. Okay, but the most important thing is the rho, okay, this symbol over here, rho, biasanya saya tulis macam ni, okay, is the density of the liquid. G is the gravitational acceleration that we know as 9.81. Okay, meters per second squared. And the SI unit, the unit for pressure, the unit for all pressure is the same, okay, which is Pascal. Either Pascal atau Newton per meter squared atau kilogram per meter per second squared. But the most easiest to remember is Pascal. Okay, so please remember this. Okay, now because of this formula, we notice that there are three factors that affect the pressure in liquid. How strong the pressure in a liquid is affected by three things. Number one, the depth of the water. Okay, so, and we will look at this. No, actually we have to look at this now. If you remember the situation just now, right? The dam, okay, so the dam is like this. We find that since the water level is this high, right? We find that the deeper the water is, the water comes out a lot further. And so we find that the bigger the depth, when H is bigger, the bigger the depth of the water, the bigger the pressure. And this is the first thing we need to understand. Okay, the deeper your water is, the bigger the pressure. That's why when you swim, let's say if you are a person who swims, when you go swimming, right, the deeper you go inside the water, you feel a lot more painful in your ears. And I don't know whether anyone of you experienced this before. If you swim at shallow places, your ears won't be so affected. But if you dive deeper and deeper and deeper, your ears akan terasa itu sakit. Because there's a lot of pressure that is pushing on your ears and your eardrums. So you will feel pain in your ears because the ears is sensitive. Okay, because the deeper you go, the bigger the pressure. Okay. Secondly is the density of the water. Okay. So we find that because of the formula, take a look at the formula. Formula is all one line, right? So if my rho increases, okay, if my density increases, my pressure will also increase. Okay, for example, oil and water. Okay, between oil and water, which is more dense? Mana yang lebih tinggi dia punya density?
Water.
Water. Okay, so if you ever swim if you swim inside oil and if you swim inside water, right? Okay, and you will swim to the same depth, kalau dalam kedalaman yang sama, okay, you will feel more pain in your ear in water berbanding dengan oil. Of course, nobody wants to swim in oil but the idea is there Okay, the bigger the density, the bigger the pressure. Okay, and then of course, thirdly is the bigger the gravitational acceleration, okay, the bigger the pressure as well, bigger the pressure in liquid. So pressure in liquid kiranya is one of the easiest things to remember All three also is the bigger the bigger. The bigger the depth of the water, the bigger the pressure. The bigger the density of the water, of the liquid, the bigger the pressure. The bigger the gravitational acceleration, the bigger the pressure. But of course, point number 3, because we are always kita selalu di bumi kan. So since kita selalu di bumi, we don't really talk about the gravitational acceleration much lah. But let's say if you want to compare the moon and Earth, okay, on Earth we feel more pressure because there's bigger gravitational acceleration compared to the moon. Okay, but of all the three, the most important to remember is the first one. Okay, the depth of water. Okay, and I want to talk about this. The depth of water. So let's say this is this one, right? Okay, depth of water dikira, let's say ini adalah seorang penyelam. Penyelam, jangan kau salah sangka, okay? So this is a penyelam. So the depth of water is counted from the surface until where the person is. This is H. Okay, bukan, okay, dari dasar laut sampai ke ini. Bukan, ini salah. Okay, dia dikira dari permukaan air sampai ke sini. Okay, and the reason for this is, think about this, people. So the reason for this is, pada tahap itu, okay, at this level, the water all over here, so imagine all this as water molecules lah. Okay, the water molecules yang menghentam dia ke sini. So the person is feeling all the water molecules on him because of the gravity. Okay, gravity akan menarik the water molecules, menarik ke arah dia. So dia akan rasa the pressure lah. Okay, dia bukan the water molecules here kan, dia naik ke atas. Tidak. Okay, because ini tidak ikut gravity. Okay, we follow the gravity. So the more water there is above you, the bigger pressure you feel. I repeat, lebih banyak air di atas kamu, lebih tinggilah dia punya tekanan. Okay, the higher the pressure. So the deeper you go into the water, okay, let's say for example here, this is situation number 1 and situation number 2. The deeper you are in the water, okay, the bigger the pressure you feel. Okay, and of course the bigger your kesakitan. Okay, so that's the 3 factors that affect. Now the one thing that we need to remember is that the pressure in the liquid is not affected by the shape or the cross-sectional area. Okay, take a look at these 5 different shapes. 5 different shapes, as I said just now, pressure is only affected by 3 things: the depth, the density, and the gravitational acceleration. Everything else doesn't affect the pressure. So it doesn't matter what the shapes are. Doesn't matter what the shapes are. If the shape is different, kan, all these 5 situations have the same pressure. Because the height is the same, the height is the same, the height is the same. So the shape doesn't affect. Yang lebih ketara yang beginilah. Look at this one. The shape is bigger, right? Okay, but the shape is bigger than this doesn't mean that this and this have different pressure. No. Okay, very important thing to do because we are very affected by shape. Kita dapat bentuk yang besar kan, terus kita fikir, oh okay, ini adalah banyak air begitu. Not necessarily, okay, the shape doesn't affect. It is the height that is important. As long as they are in the same height, then the pressure is the same, regardless of the shape. The third one is, so if let's say in this situation, this is also the same lah. If you notice this tabung uji, this tabung uji kan dia berdiri tegak macam ni kan. Then lepas tu kalau kita kasih sengitkan begini kan, we find that the pressure that is experienced is the same because the height is the same. So it doesn't matter whether you kasih straight or you kasih this one kan, as long as the height of the water is the same, okay, the pressure of the water will be the same throughout. Okay. All right, so let's look at a few problems that involve pressure in liquids. So these are a couple of calculation questions. So they say that a group of scientists are planning to build an undersea research lab using specially designed glass panels that can withstand a maximum pressure of 2575 kilopascal. Okay, let's talk about this. So we know that the pressure unit is Pascal. So if it's a kilopascal, what do we need to do with this 2575 if I want to change it to Pascal? Anyone? How do I change kilopascal to just Pascal?
Times 1000.
Times 1000. Okay, 2575 times 1000. Okay, we need to change it to Pascal because we know the pressure formula as in Pascal. Okay, now if the density of the seawater is 1030, what is the maximum depth? Okay, maximum depth refers to the letter H. Okay, so, gosh, I hope in the video, you don't see all this thing coming up from my nose. Okay, so pressure equals to rho GH. Okay, and since pressure is 2575 times 1000, okay, our rho, which is the density, is 1030. Okay, gravity is 9.81. This is a standard for all of you. Okay, and then we find the value of H. Okay, can you calculate H for me, please?
254.84.
The rest of you, okay, 254.84.
Yes, sir.
Unit?
Meter.
Okay, meter. Okay, yang lain okay boleh Okay, let's continue So this is a situation slightly different, okay? Now the diagram shows a U-tube, so this is the original meaning of U-tube not our Y-O-U-T-U-B-E yang ciplak itu, okay? Walaupun saya guna YouTube juga, tapi saya mesti bagi tahu. The U-tube actually comes from this tube, which is in the shape of a U, okay? Now this tube is also known as a manometer. Okay, it's also known as a manometer, and we will see it next month when you come back to school. Okay, so in a U-tube, I fill it with two different kind of liquid. Okay, so liquid Y and liquid X that have the different density Okay, so liquid X, the density is 80. Density of Y you need to count. Okay, now, so but you see, we find that when we fill in the U-tube with the two liquid, right? The two of them, their interaction, of course, they don't mix. Okay, and then we find that this liquid X, macam dia lebih banyak menolak berbanding dengan liquid Y. Okay, notice there's a difference over here. Okay, this X liquid looks like it's pushing So the thing that I need to teach you is that at this level, okay, at the level where liquid Y and liquid X meet, di mana mereka bertemu, okay, the pressure is the same. That's a very important thing. Okay, the pressure where they meet is the same. So that means we're talking about rho GH for X must be equal to rho GH for Y. Okay, and since the X density is 80, so 80 times 9.81 times, okay, so what is the height of X? The height of X is the topmost until the place where it is equal. So we're talking about 10 cm. Okay, sini sampai sini. Bukan sini semua. Bukan. Okay, kita abaikan yang di bawah. Sebab di sini ni dia sudah seimbang. So kita ambil yang ini sahaja. Okay, so this is 10 equals to, now the row of Y we want to count, G is 9.81, and then the height of Y is 8 cm, like that. Okay, can you calculate for me the density of Y, please? Sorry, how much? 100
100.
100 what? Unit for density?
kg meter.
Kg meter negative meter cube lah. Okay. All right. Next. So let's talk a little bit about application. Okay, the application of pressure in liquid in our lives. So the first one is why we put the water tank on top of the house. Okay, so if this is a house, you want to put the water tank on top of the house. Nobody, okay, at least not that I know of nobody puts the water tank at the same place as they put the door. Okay, let's say you put a water tank over here. Nobody puts a water tank over here unless you have a pump. Okay, but putting a pump actually you increase the cost you have more cost because you have to buy the pump then pump the water Okay, but if the water tank is at the top of the house, you are actually taking advantage of the height. Okay, of the height of the tank. So the difference in the height between the water level in the tank and the water tap, okay, so let's say your tap is over here, right? There's a difference in height over here. So the liquid over here will have pressure and it will push the water, okay, towards the tap. So you see the difference in height between the water level in the tank and the water tap produces a high water pressure on the tap. Okay, so that explains why sometimes when you open the tap kan, the water kenapa dia macam lemah ini. Okay, and we find that happens especially if you're living in apartment and you're living nearer to the top. So let's say for example apartment lah. Okay, apartment, let's say you have 17 floors lah. So this is first floor and this is the 17th floor. Now usually on the 17th floor at the top over here, okay, is all these big tanks lah. Okay, all the big tanks yang akan supply water from the 17th floor to the first floor. Okay, so we find that people living on the first floor, dia punya air itu sangat laju because there's all this height. But the people who are living on the 17th floor, which is nearer to the tank kan, laju tu laju lah, tapi tidaklah selaju dengan yang satu. Okay, because their position is nearer to the tank. So the height difference is very small compared to the first floor. Okay, and that's why sometimes in apartment kan, people who live on the ground floor, their houses are more expensive. Not just because tidak payah naik tangga, but also because there is this convenience. The water pressure is usually very high. Siok lah diorang mandi tau kalau di first floor. Sebab dia punya tekanan air sangat tinggi. Kalau kamu 17 floor kan, kalau air itu tidak banyak, memang sangat sedih lah. The water will be like, oh kenapa ni menitis pula ni air, bukan dia keluar. Okay, because of the height difference. So height difference, where you put the tank in your house is very important. So next time when you're big, you want to build a house, please remember, okay, don't put the tank on the same level as your kitchen or the toilet. Okay, there has to be a difference, okay, in the height of the tank, so that you don't have to buy extra stuff. But if you have no choice, you really have to put the tank on the same level as the house. Terpaksa kamu beli water pump lah. Okay, you buy a water pump so that the water pump will pump the water into your tap. Okay, secondly, this IV bag. Okay, so people who do chemotherapy or people yang kena masuk air dalam badan makan, okay, atau kena masuk darah, we always put the bag higher than the patient. Okay, we always put, so a bag of intravenous liquid is placed in a position that is higher than the body of the patient because there will be a difference in the height. Okay, the difference in the height will push the IV bag, the IV into the body of the patient. Okay, so the rate of flow of intravenous liquid into the patient's body depends on the height of the bag, can be controlled by the adjuster. So this adjuster ni dia akan menentukan lah berapa banyak yang masuk dalam sesaat. Okay, but the height also plays a difference. The higher you put the bag, the faster the liquid will flow because there's more pressure. Okay, remember pressure and height okay, is directly proportional. The bigger the height, the bigger the pressure. Okay, so if you, let's say next time you end up in a hospital and you really want to get this over and done with, because usually one bag will take about maybe 2 to 3 hours lah, okay, untuk masuk air ke dalam badan kamu. So if you really want it to be done fast, right, kau gantung di atas ceiling lah. Okay, kau gantung di atas ceiling, kau tunggu di sana kan, cepat itu air masuk. But actually it's not good lah. Okay, air masuk ke dalam badan kamu dengan kadar yang laju is not good. That's why there is an adjuster. Okay, so that you can adjust how much water goes into your body so that kamu punya body tidak kena shock lah. Okay, so the question is, what if this guy put the hand up here? Astaga, sorry. Let's say he put his hand up here. Okay, and the hand is higher than the bag. What will happen? Has anybody experienced this before? If you kena cucukkan, then you put your hand higher than the bag. What happens? Anybody know?
The water stop.
Not only the water will stop.
Slow.
Not only the water will slow.
Reverse.
Oh, back balik terus keluar darah.
Betul, okay. The darah from your body will masuk ke dalam the system, which is not good lah. Okay, so yeah, jangan kau bangga-bangga. Wow, saya tengok ni semua orang, saya ada intravenous bag. Dan terus darah keluar. Dan terus kau kencang. Wah, ada darah keluar. Okay, padahal you're just It's just pressure. It's just liquid pressure yang menyebabkan, because the blood is higher than the intravenous bag punya liquid. Okay, so the blood will flow out. That has happened. That happens a lot of times. Okay, we always see this. Okay, so the same thing as the dam. So the wall of the dam, if kalau kau tengok dari pandangan tepi kan, and actually most dams also you will see lah. The wall of the dam kan dia akan sengit begini. Because over here dia tidak banyak pressure. Tapi over here, there's a lot of pressure. So number one, the wall of the dam is built thicker at the base because the water pressure increases with them. Sini sini tekanan tinggi, sini tekanan rendah. So terpaksa kita bina dinding yang lebih tebal untuk menahan the high pressure. Okay, the thicker section of the dam is able to withstand the high water pressure. Now the penstock, okay, is at the lower section. Tempat di mana air keluarkan, macam kamu nampak dalam video tadi bahkan. Okay, dia akan di sini, and it will produce a fast flow of water to drive the turbines. And this is the basic operation of a hydroelectric dam. Okay, hydroelectric dam. Okay, hydroelectric dam means we use water, we use liquid pressure to turn the turbine, okay, so that it can generate electricity. How does it generate electricity? We will learn in a later chapter. I think chapter 4 or chapter 5. Okay, but what you need to know is that apa yang memusingkan this kipas is this high water pressure. Okay, the high water pressure will move the fan so that the fan, the turbine, can generate electricity. Okay, and this is one of the biggest uses of pressure in liquid. Okay, construction of a dam, and also how a hydroelectric dam can generate electricity. Okay, now this last one is something that I actually want you all to do tomorrow, but I will talk about this tomorrow lah. But this is a siphon lah. So let's say for those of you yang bela ikan kan, you will know lah. You will know how to do this. How do you take out all the water, put it into the pail, or how do you drain out all the water? Okay, usually kamu akan sedut bahkan this side, and then when the water comes akan cepat-cepat kau letak di sana. Okay, so what is actually happening? Okay, so a siphon atau yang kamu panggil hose lah, okay, is used to transfer water from a higher region, so this is the high region, okay, to a low region. Okay, so one end of the tube is filled with water that is placed in a tank of water at high position. The other end is at the low position. So the flow of water from D, okay, produces a region at lower pressure at point B. The flow of water from ND, yeah. Okay, so apa yang akan berlaku is atmospheric pressure yang kita belum bincang lagi lah. Okay, we will talk about this in the next subtopic. So actually, what is pushing the water into A and masuk ke dalam D sini, okay, is the atmospheric pressure. But what you need to know is that because there is a height difference, okay, okay, the pressure in liquid now will also help to push the water into the siphon. Okay, and this is one of the biggest uses of siphon lah. That's why we can take out water from the aquarium very easily. Bukan kau ambil gayung lepas tu satu kau kasih keluar. Tidak. This one very fast. In a matter of seconds. Okay, siap sudah. Okay, kamu boleh sedut semua air keluar, then you can clean the water tank or the aquarium lah, depending on what you use it for. And those of you yang bela ikan, you will know this lah.